Let's solve the following trig equations in 0 to 2 pi here, making sure that we leave any of our answers rounded to 4 decimal places. First things first, we do want to get our trig expression completely by itself. So first thing I'm going to do is add that 1 to the other side to get 3 sine x is equal to 1, and divide the 3 out to get sine x is equal to 1/3. In order to solve the following equation, we do need to take the inverse sine so that we cancel that out on the left, and x is equal to inverse sine of a 1/3. Inverse sine of 1/3, so you can just type this in the calculator, and when we type that in the calculator, we are given that theta is equal to 0.3398 when we do round to 4 decimal places. You also want to keep in mind, if we are finding all solutions of sine, our first solution here, 0.3398, we want to find all solutions within a 0 to 2 pi period. So to see if there's any other solutions here in this period, you do want to take theta is equal to, you want to do pi minus your alpha here to get any other remaining solutions here. So if we do that, pi minus our 0.3398, again, calculate that, we are given our second solution, which is going to end up being 2.8018. In order to work our second equation here, so let's get our cosecant by itself. So let's add 2 on each side, which is going to give us cosecant of x plus pi over 8 is equal to 2. In order to get rid of cosecant on each side here, or working with cosecant here, when we're working with trig equations, we want to figure out some way to convert them to an equation dealing with sine, cosine, or tangent. What I could do at this point here is I know that cosecant and sine are inverses of each other. So putting that in here, cosecant is going to be the inverse of sine. This will give me sine of x plus pi over 8. And taking the inverse of the right-hand side is going to give us a 1/2. All right, so take the inverse of each side. Inverse of cosecant is sine. Inverse of 2 is 1/2. So that after this point here, if we're trying to solve for x, well, we need to take the inverse sine of each side to cancel out our sine and sine inverse here. We are left with x plus pi over 8 is equal to the inverse sine of 1/2. Dropping down our left-hand side, x plus pi over 8, inverse sine of a 1/2 is equal to a pi over a 6. In order to get our first solution here, we are going to subtract that pi over 8 to each side here, that x is equal to pi over 24 for our first solution. Now, keep in mind, we want to find all solutions within the parameters of 0 to 2 pi. So far we know that x plus 8 is equal to the pi over 6, right? We calculated all of this. X plus 8 is equal to sine inverse 1/2. So we got that x plus 8 is equal to inverse sine of 1/2, which ended up calculating to pi over 6. So that's the piece that I want to pull out here. We have our left piece here, which is our x, right? X, or whatever happens to be inside the parentheses here. So for us, that is x plus pi over 8. And we got that that equals sine inverse of 1/2, which is actually pi over 6. Now the stipulations of sine, of solving sine trig equations, say that x is equal to alpha plus 2n pi. Again, we're not using the 2n pi for this because we want all solutions within 0 and 2 pi. So we don't want to keep adding and finding all those other solutions, just the ones between 0 and 2 pi. So that means for our first part of our solution, when we solve this bit here, that is this first piece. For the second piece, it says x equals. Now our x is the x plus pi over 8. Again, x plus pi over 8, this piece here. So for our second piece, I'm going to write down x plus pi over 8. And that is going to equal pi minus our alpha, which is pi over 6 here. Once we solve both of these equations here, these will give us the solutions within 0 and 2 pi. So if we subtract pi over 8 on both sides over here, we are left that x is equal to, well, pi over 6 minus pi over 8, once we get common denominators there, we are going to be left with pi over 24 as our first solution. We're also going to subtract pi over 8 from this side here, but x is going to equal to our pi minus the pi over 6 minus the pi over 8 from here. So we need to do pi minus pi over 6 minus pi over 8. When we calculate that, we will be left with a 17 pi over 24 as our second solution within 0 and 2 pi.